Hello everyone, I hope you all are having a wonderful day. So in my last video, we have already discussed about what are union and intersection of sets. Then we have also discussed about complements of a set, then about how to represent using Venn diagrams and everything, right? Now it's time to use all this knowledge and do some practical problems based on union and intersection of set. To do some practical problems to get a fast answer, we need to have some formulas. So in this section, we are going to derive the formula for A union B. For that, like a fast formula to be used to find the union or intersection of a two sets or three sets. Okay, first let's directly go with a Venn diagram. You know that there are two sets here, A and B. The first portion of the set is A minus B. What is this A minus B? Set of all elements of A and which does not belongs to B. That is only the elements of A and they do not share elements with B. Again, the middle portion is the A intersection B. What is A intersection B? A intersection B is nothing but it is the all the elements which belongs to A and also belongs to B. What is B minus A? All the elements of B and which does not belong to the subset A. So what is this actually A union B? A union B is nothing but it is the number of elements of A minus B plus number of elements of A intersection B plus number of elements of B minus A. Right? I hope it's clear. So what is this n of A minus B plus n of A intersection B? This is nothing but all the elements of A. So you are grouping it together. Then you're writing it as n of A and plus n of B minus A. You have seen here two elements. These were not in the formula or not while adding. You didn't see that, right? Just for a convenience, I have added a term n of B minus A plus n of A intersection B. So I have written wrong over there. I have to correct it. So here that is A intersection B. You have just added an A intersection B and also you have subtracted an A intersection B, right? So just to derive a formula or to make up a formula, we have done that. Again, you can say that n of B minus A, that is this portion plus n of A intersection B. What is that? This is the complete elements of set B. That is what written here. So what is left over here? N of A intersection B minus n of A intersection B. Or you can simply as logically you can think like if you wanted to take union of the set A union B, you can take all the elements of A and all the elements of B. But you can see that this A intersection B is repeated two times, right? So you are just minus subtracting one time the A intersection B, because with A subset also A intersection B is included and also with the B subset also A intersection B is included. So you have to subtract one time A intersection B from n of A plus n of B to get n of A union B. Or if you want to learn it using derive the formula, you can take separate sets, that is different sets A minus B plus n of A intersection B plus n of B minus A. You can, if you take n of A minus B plus n of A intersection B, it will give you n of A. Again, n of B minus A plus n of A intersection B will give you n of B. You have one leftover A intersection B and you have to just write it here. And this is the formula to find the practical problems using union and intersection of sets. It's very easy. It's nothing complicated. It is just n of A union B, n of A union B is equal to n of A plus n of B minus n of intersection B. So this is the formula for the practical problems on union and intersection of sets. Now let's discuss another one factor of it. If the disjoint sets, if A and B don't have any common elements, in the before figure you have seen that they have some common elements, but suppose if there are no common elements, that is they are both disjoint sets, A and B are separate sets. In that case you can say that A intersection B, that is the common set, is empty set. So you can just write n of A union B as what? N of A plus n of B, because they are both separate sets and you just have to add the elements of both the sets to get the union of that set. I hope it's clear. Now let's discuss about, we have just done with two sets so far. Now let's discuss the union with three sets. That is n of A union B union C. The formula is n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. What is this n of A intersection B intersection C? That is the middle portion here. This middle portion is the n of A, that is common for all the subsets A, B and C. That is n of A intersection B intersection C. Now let's see how to prove that. It is given that n of A union B union C is same as n of A plus n of B union C minus n of A intersection B intersection C. So if you can, from this section, you can derive this formula, then you can say that this formula is valid and you can use this for several questions. So let's directly prove that. For that, you know that n of what is B union C? That is what expanded here and written. What is that? N of B plus n of C minus n of B intersection C, right? Again, minus n of A intersection B union C. We don't know what is this term. So let's try to make it into a simpler terms for our convenience. N of A intersection B union C. You can use your distributive law here. So what it happens, because we know the formula for A union B. A intersection B union B intersection, sorry, A intersection C. A intersection B union A intersection C. Now you can treat this as separate elements. So you know already what is the formula for n of A union B, right? What is it? Consider here A as A intersection B and A intersection C as the element B. So let's directly write the formula for it. What it is? N of A intersection B plus n of A intersection C. Why I am writing like that? Because we know the formula of n of A union B is what? N of A plus n of B minus n of A intersection B. Here A is A intersection B and B is A intersection C. So n minus n of A intersection B intersection A intersection C. Right. So this is what it is, B, and this is A and this is C. What is this A intersection? N of A intersection B is what? This side, right? Please look at the Venn diagram. Again, N of A intersection C is what? This side. So what is the common side in this one? This is the side. That is N of A intersection B intersection C. So now this term you have converted into three terms. What are they? N of A intersection B plus N of A intersection C minus N of A intersection B intersection C. I am writing it again. N of A plus intersection B plus N of A intersection C minus N of A intersection B intersection C. Now substitute this value in the formula, this one. So what you will get? N of A plus N of B plus N of C minus n of B intersection C. Again, minus is there, so minus n of A intersection B. Again, minus n of A intersection C, right? If you find any difficulty to follow, please comment under my video. I'll be writing it, or you can also write me under my email ID jojoslearningclub@gmail.com. I'll be there to help you out. Okay, so don't worry about that. Now let's directly compare minus n of A intersection C. Again, minus minus, that is what? Plus n of A intersection B intersection C. You can see that now we have found the formula for the A union of B union C. That is what? N of A plus N of B, number of elements of A plus number of elements of B plus number of elements of C, subtracting the common elements of A and B, common elements of B and C, common elements of A and C, then again adding plus number of all the elements of common elements of A, B and C. So that is the formula for A union B union C. Okay, so we have already derived, and now let's start our work problems. Before going to work problems, we'll do an example problem, so you will have enough confidence to do the work problems based on exercise 1.6. So let's do a work example problem. If x and y are two sets, so we have two sets here, x and y, such that x union y is already given. What is x union y? Both the elements of x and y. That is what 50 is given, right? Again, what is given? X has 28 elements. So n of x union y is 50. N of x is what? 28 elements. And n of y is what? 32 elements. Okay, so from this problem, we have to find how many elements does x intersection, that what are the common elements in it. To find that, The easiest way is to use the formula n of x union y. What is that? N of x plus n of y minus n of x intersection y. We know already what is n of x union y is. What is that? 50. Again, what is n of x? That is 28. Here is n of y, 32. If you know all the elements of an equation and only one variable, then you can easily find this variable, right? So you can find n of x intersection y is what? Taking all the constant terms to one side, you will get 28 plus 32 minus 50. That is what? 60 minus 50, and that is 10. So 10 is the common elements by which by x and y share. So that's all for this section. And on my next video, we'll cover about the exercise problems based on 1.3, based on the practical problems on union and intersection of two sets. So let's see you over there. Bye bye.